Dear friends, Mass Aspirants is a collective of mathematics students, research scholars and faculty members across India. And we used to arrange several online problem solving sessions and online test series to help the students who are preparing for different national level competitive examinations. As a part of that series today, we have a special session focus on TIFR GS 2024 examination, which is going to happen on the coming 10th December. So today we have Mr. Aviral Srivastava as the resource person. He is currently pursuing PhD at IIT Gandhinagar. Mr. Aviral qualified IIT JAM examination and he did M.Sc from University of Hyderabad, and he qualified CSIR NET JRF GATE examination and also NBHM Doctoral Fellowship this year. Currently, he is pursuing PhD in some areas related with number theory. So today, he will discuss with you selected problems from analysis part, which can be expected for TIFR examination. So I'm sure that today's session will be really helpful to all of you who are preparing for these examinations. I would like to thank Mr. Aviral for inviting our invitation and joining with us. I hope that all of you will enjoy this session. Welcome everyone to this program. Welcome.
Good evening, everyone. Thank you for joining the session. So today we will be discussing some problems that are asked in TIFR previous year question papers, and we will be focusing more on real analysis and a little bit of metric spaces. So let me share the screen. Actually, I thought to include there were a lot of problems. I thought to include some good problems, but still I couldn't include all of them, or couldn't include most of them that I wanted, but still we have almost 20 to 25 problems, and we'll be discussing them. So let me share the screen. So first problem is f is given as the continuous function such that fx is greater than or equals to x cube for all x belonging to interval 0 to 1. Also, it is given that integration from 0 to 1 fx dx equals to 1 by 4. Then fx equals to x cube. So question is it true or false? So let me begin. So in the problem, it is given to us that fx is greater than or equals to x cube. So let me define a gx. Tell me how many of you know the property that if hx is a function from a interval a to r such that hx is greater than or equals to 0, comma, this condition is also given, then this implies hx equals to 0. This is kind of a standard problem in analysis. I mean Riemann integration. So we will apply this to do the problem. So gx is let us take gx as this. Then of course, first of all, because of the given condition, gx is greater than or equals to 0. Right? Now take the integral. Yeah, so somebody was saying it should be continuous to claim that hx equals 0. I mean that only. So if hx is continuous such that hx is greater than or equals to 0 and the integration is 0, then hx equals 0. So in this case, what we will have this. Now since the integration of fx in the interval 0 to 1 is given as 1 by 4, and the integral 0 to 1 x cube is also 1 by 4. So the integral of this function gx is 0. Now since fx is a continuous function, x cube is also a continuous function, so their difference is also a continuous function. So gx is a continuous function which is greater than or equal to 0, whose integration in the interval 0 to 1 is 0. It implies that gx have to be equal to 0. It implies that fx equals to 0. So this statement is true. Any doubt?
No, sir.
Okay. Next problem. So it is given that ABC are positive real numbers such that this condition follow. Then they are asking, is it necessary that A plus B plus C have to be equal to 3? And this is really interesting problem. So to do this, there are two methods that we can apply. One is to apply Cauchy-Schwarz inequality. Most of you must be knowing this. Or even we can apply AMGM inequality. Whatever. So we can apply AMGM. What will happen is that using AMGM inequality, this should be greater than or equals to 4 times. And note that ABC are given as positive, so we can actually apply AMGM. Fourth root of ABC, right? 4 times fourth root of ABC, and 1 plus is again greater than or equals to 4 times fourth root of 1 over A times B times, right? Now what is happening? This then imply correct? So what is happening in this case is that this inequality that is coming due to AMGM inequality is actually a equality as mentioned in the question, right? So what happened, to have this 16, we need to have the inequality. In order to, let me call it 1. In order to satisfy equation 1, which is given in the question, AM have to be equal to GM, right? Because when we apply, when I applied AMGM inequality, it is automatically coming as this quantity is greater than or equal to 16. It means it has the least value 16. So, and we want it to be equal to its least value. So, only case when it could happen is when AM is equal to GM. Now, can somebody tell me when equality comes in AMGM inequality?
If all the terms are equal. A equal to B equal to C.
Yeah. When A equals to B equals to C, right? So if I plug in A equals to B equals to C, what will get? One plus 3A times 1 plus 3 upon A is equal to 16. Now you can easily solve for A, and what you will get, A equals to 1. And this will imply A plus B plus C equals to, oh sorry, 3. Because A, B, C were equal and value of A is 1, so value of B and C should be equal. Got it? So this is also true. And other ways to apply this Cauchy-Schwarz inequality. And again, what you will observe is that in that case, the equality will occur. And equality in Cauchy-Schwarz inequality, when does that occur? If one vector is a multiple of other vector, right? So what you do in this case, if you want to apply Cauchy-Schwarz inequality, take the vector as and other vector as right, and then you will observe that this case will occur in order to get it equals to 16. Okay, and this can be possible only if b equals to lambda u, but then it will imply 1 is equals to lambda by comparing the vectors. So it implies that root a equals to 1 by root a, comma root b equals to 1 by root b, comma root c equals to 1 by root c. And then again, since ABC are given as positive, so yeah, so yeah, so it will give you a equals to 1, b equals to 1, c equals to 1. All right. Okay. Now here's one more interesting problem. There exists a subset A of n with exactly 5 elements such that sum of any 3 elements of A is a prime number. This is a very nice problem, not a kind of proper analysis problem, kind of little bit of number theory problem. So in order to tell you how you can approach this kind of problem, see, instantly you can't have any idea if it is possible or not, or to get the counterexample. So when I started to solve this problem, I took 2 or 3 examples. In all those examples, so first let me make some remark. First remark is that in order to such a set here A can't contain a even integer. Can somebody explain why?
All odd numbers, all primes are odd numbers except 2.
No. I am not talking about the prime numbers. I'm talking about the elements of A. Elements of
If
A are 5 elements, right? They are
if
only
we sum,
from
yeah, if we sum 2 odd numbers and then add an even number with it, we will get an even number.
Yeah, and it won't be prime. And similarly, if you have 2 even numbers, then also add 2 even numbers, add 1 odd, again it will even. And if you have more than 3 even 3 or more than 3 even integers, then again adding all those 3 even integers will give you even integer which is not prime. So such a set can't contain even integer. Second fact, it can't contain. So it implies that A have to contain all the odd numbers, right? A contain
Yes.
only odd. Okay. Also, it can't contain consecutive odd numbers. Odd numbers. Why?
Consecutive odds when added will give even.
Yeah. Consecutive odds when added will give you even. So kind of 3n plus 1 times sorry, not 3n plus 1, 2n minus 1 plus, not even, it will give a divisor of 3. 2n plus 1 and plus 2n plus 3, right? These will be the 3 consecutive odd integers. So when you will cancel out 1 it will give you 6 and plus 3, and it is divisible by 3, so it is not a prime, right? Now, so when I started with this problem, so I took 2 sets containing random odd numbers, and I observed that there exists at least 3 numbers that are divisible by 3. Why is it so? I'm explaining. Okay, so so one more observation. Third, there can't be three elements in A having same remainder when divided by 3. We know that any number in a natural number can be written either in the form 3m or 3m plus 1 or 3m plus 2, right? Only 3 possible choices. So what I'm saying, there can't be 3 elements in A having same remainder when divided by 3. So you can't have numbers of the kind 3m1 plus alpha, comma 3m2 plus alpha, comma 3m3 plus alpha. You can't have 3 numbers in this form where alpha belong to 0, 1, 2. Why? Because if you add them, you will get m1 plus m2 plus m3 plus alpha, right? Which is divisible by 3 and hence can't be prime. Is it clear till now?
Yes.
Yes, sir. Yes, sir.
Yeah. So there can't be 3 elements in A having remainder when same remainder when divided by 3. So what is the worst case is that 2 elements have the same remainder and 1 element have the other remainder. So using this, we can do the fourth observation, is that at least one of 0, 1, 2 will be the remainder of each one of 0, 1, 2 will be the remainder of at least one element in it, right or not? Tell me.
Yes, yes.
What? Can you repeat it again? Okay, so I'm explaining again if somebody wanted. So what is happening that none of 3 elements in A can have the same remainder. So at most 2 elements can have the same remainder. So suppose 2 elements have the 0 remainder, then 2 elements have the 1 remainder, then the last element, because there are 5 elements, the last element have to have the 2 remainders. Similarly, if 2 elements have remainder 2, 2 elements have remainder 1, then at least 1 element in those 5 have to have remainder 0. So this is why they have to have all the reminders when divisible by 3. So this implies that we can have 3 elements of the kind. So there are 3m1 plus 1, 3m2 plus 2, 3m3 plus 0 elements in A. So there will be 3 elements of this kind in A, and when you add them, you will get 3m1 plus m2 plus m3 plus 2. And hence it is again divisible by 3. So it is not possible to have a set of 5 elements such that sum of any 3 elements of that set is prime. So it is false. It was a very nice problem. And everything depends on the fact that when you divide some number by 3, it either give a remainder 0 or 1 or 2, and then some trivial or non-trivial observation. All right. Okay. Let me begin with this. So given a continuous function f from q to q, there exists a continuous function g from R to R such that restriction of g to q is f. Is it possible? Any guesses? Any guess from anybody?
Yes.
Yes, no. Actually, it is not possible. Why? I'm explaining this. So, why it is not possible? Because they are asking for any f, so I will give a count example. So, consider f as follows. One, if x belongs to Q intersection 0. Is it continuous on Q? Is it a continuous function on Q? Tell me. Anyone?
Yes, sir.
Yeah. It is continuous function on Q because Q have the gaps and I utilize the gap by introducing pi, which is an irrational number. So we can separate Q using an irrational number, and we are utilizing that separation to define a continuous function. So we have this continuous function. Now suppose some Q from R to R is extension of Q. Then what will happen? Fx equals to gx for every x belongs to Q. Right? This is what extension means. That the functions will be equal in their common domain, and then the extension function will be further defined on R. So suppose such extension function g is there, and then it will satisfy fx equals to gx for every x belongs to Q. Now, because of continuity, this will imply fx equals to gx for every x belongs to Q. Is it fine? Or somebody have doubt that how I came to inequality for all R? Sorry, came to equality for all R. Is there any doubt? Actually, it is due to sequential criteria. So, what is happening? Since they are already equal in on rational numbers, so suppose bi belongs to irrational number, then you can find a sequence of rational numbers, call it bi, such that bi to bi. Now this will imply, since they are the sequences of rational numbers, so they are equal on the sequence points, and then take the limit. This will imply f by equals to g. And since bi was arbitrarily chosen irrational numbers, so fx equals to gx. Since fx equals to gx, so it implies that wait, let me define it on this one. So then gx will be defined like this, and of course such a gx is not continuous on pi, right? Is it continuous on pi?
No.
Yeah, so it is not continuous on pi, so hence we got a function which was continuous on Q, but there was no such extension was possible. right? So it is false. Yeah, so here's interesting problem. So let A is a countable subset of R, which is well ordered with respect to the usual ordering of R. Then A has an order preserving bijection with a subset of N. What they are saying that A is a countable subset of R, which is well ordered. What well ordered means that every non-empty subset you pick always have a minimum element. For instance, natural number is a well ordered set, right? So then they are asking that A has a order preserving. What does order preserving means? That if x1 is less than equals to x2, then fx1 is less than equals to x2. Where less than equals to denote the order, which can be defined anywhere. So this is what order preserving means. So they want an order preserving map, which is a bijection. Can we have, or can we not have? Can we have a counterexample? Any guesses? Okay, let me do. Here's an interesting property of N that we can utilize to give a counterexample. Interesting property is that set of natural numbers don't have a supremum. That is because it go to infinity, so it do not have a supremum, and we will utilize that. How? Yes, let me define a set. Union call 2. Okay. Now this is set A. Is it possible to define a order preserving bijection with a subset of N? No. Why? If it is order preserving, what is the least element of A? Can somebody tell first? Which is the minimum element of A? -1, right? And then minus half, and then minus 1/3, and it will go. So if F from A to N is order preserving, bijection, then this should be the case. Isn't it? Right?
Yes.
But the problem is, because of the ordering that we are taking is of R, this 2 is the greatest element. But this mapping will go on, and the greatest element of this will be 2. But N do not have any great element or any maximum element. So this function cannot be a order preserving bijection. Or I mean, any function from A to N can never be a order preserving bijection, because this chain will go on, but it have to stop at this maximum element, which is not possible because N do not contain any maximum element. So this is false. Although this is the example, can somebody give me an example of A for which there exists a order preserving bijection?
Take Q, right?
Yeah, Q is possible, and simplest possible set is N itself. You can define Fn equals to N. Very trivial. Or set of even numbers, then you can define N by 2 and so on. Right? So there exist sets which can have the order preserving bijections, but not every set. One such set is this A, which cannot hold that property. Okay. For a closed subset A, there exists a continuous function f on R which vanishes exactly on A. Can somebody answer this? It is not that difficult. Do you know any function? It is not that usual function that we encounter usually. Do anybody know such
We
a
can
function?
consider the distance function.
Yeah, very nice. So take the set A. Now define the distance function dx. The definition is take the infimum of by belongs to A and with the usual metric also you can take. So try, yeah. Take the infimum by belongs to A and take the distance of x and y. Now it is a function. So if suppose by belongs to A, then since we know that x minus y is greater than or equals to 0, and for by belongs to A, when you take the infimum, this we can also plug in by. So 0 is the least value that it can take. So whenever by belongs to A, Px, so d of by A equals to 0 if by belongs to A, right? And if by do not belongs to A, d of by comma A is strictly greater than 0. But for this, I have to ask why. Has a special property given to A, which is closed subset. If somehow we have some subset A whose limit points are not lying inside the same set, then it is not possible to define dx comma A as a function which vanishes exactly on it, because then such a function will give the 0 value on the limit point also. For instance, if you have a as open interval 0 1, then the distance of 1 with A is 0, because 1 is the limit point of the set which is not lying inside. So this function then will not vanish exactly on A but also on outside A, which is on point 0 and 1. So because of this special property that A is closed, it will be 0 exactly on itself because it contains all its limit points, and the distance will be greater than 0 when by will not be in A. And I will leave the exercise. It is given in many standard books to prove that dx comma A is a continuous function. This I will not. I'm leaving this as an exercise to you people that to prove this is a continuous function. Okay. Let me come to the next problem. So here it is given that f is a twice differentiable function on R such that both f and f double dash are strictly positive on R. The limit x tends to infinity, fx is infinity. Any guesses? What I mean, what is the simplest function that you know for which at least f is equals to f double dash?
E power x.
E power x. But the problem with e power x is that limit x goes to infinity, e power x is infinity, right? Can you little modify it?
e power minus x.
Very nice. So see these problems Okay, a general advice is that TIFR asks many such questions which require a simple counterexample. So whenever you see a problem, try to find a counterexample first. And if 2-3 examples that you picked, nice examples, and they satisfy the lemma, then you can somehow try to see the proof. But first, you should try counterexamples. Fx equals to e raised to minus x, and of course, it is strictly greater than r, greater than 0 on r, right? Now, f double dash x is again e raised to minus x, which is again strictly greater than 0. But limit x goes to infinity, fx goes to limit x goes to infinity e raised to minus x. So, and hence not equals to infinity, and hence it is 4. All right. This was the simplest problem. Just you have to think of a counterexample. Now, let me, yeah, this is nice problem. Is there exists a continuous function which can follow this? Can map rational to rationals and then irrational to rationals. It's not. Let me give a proof. So consider a function gx equals to fx minus x. No, before taking this function, let me tell you idea behind it. Suppose you take a function along with fx. If I add x in fx or subtract fx in fx, then it will again be a continuous function, right? But it has a special property that whenever you plug in a irrational number, fx will be give you rational, so it will give you rational, and since x is an irrational number already, it will give you rational plus irrational number, right? Whenever I plug in x here, which is an irrational number, then by the property, it will give you rational plus irrational number, right? So, sum of rational plus irrational, what it is? It is rational or irrational, what? Sum of a rational and a irrational number. Is it irrational?
Irrational.
Yeah. So this will be a rational number. Now again, if I plug in x belongs to q there, then what will happen? fx will give us a irrational number, and x is already a rational number. So again, it will be irrational plus rational, which again will give us irrational number. So this is becoming a function from R to R whose range is Q complement. And we know that image of a connected set is connected, Q complement is not connected, and then we will have a contradiction. So let me define the gx function. Gx function as this. Now it implies that by the same observation that I told you just now, for every x belong to R, gx belongs to Q complement. Fine? Is it? Is it fine?
Yes, yes.
Okay. It implies that G is a onto continuous function from connected set R not connected. This implies G is a constant function. Is it fine or not? Because there exists no non-constant continuous function which maps connected set to non-connected set, because image of a connected set is connected set, right? Other possible way that you can do is using intermediate value property, or apply intermediate value property, because if Gx take two irrational numbers R1 and R2, then there will be some rational number between them which will be taken by them. So it is not possible because its range is irrational. So you can apply IVP or this argument to show that G is a constant function. Now since G is a constant function, so it implies that Gx equals to, say, alpha, where alpha belongs to Rho. It implies that fx is nothing but x plus alpha, right? Right or not? Now can somebody tell me how can I show the contradiction now? We are just about to show the contradiction. We can show now. Is somebody? No, it is a contradiction because if I plug in f alpha, it will give 2 alpha, which is belonging to R over 2. But it is not possible because we know that image of irrational number by the given property is contained in rational number, but the image of f is not rational number, hence contradiction. See, it seems a complicated question, but you have to just apply some basic thing, and most of the problems in TIFR they ask from intermediate value property, sequential criteria of limits, or somewhat some like little arrangement of the problem, little tricky arrangement, and then you can do that. So such problems are asked like many times in TIFR, so be prepared. Yeah.
Yeah. How did you conclude that G is onto function?
Onto continuous function from R to QC, because it will take all the QCs, or not even QC. You can say on the irrational numbers, simple, on some subset of irrational numbers.
Yeah.
Because even if it is continuous and it will map R to some subset of irrational numbers, then also it have to be constant, right?
Yeah.
This is the reason. Let me write then. Not connected subset of QC. Yeah. Right. It may not be whole QC, but it will be connected. Maybe some subset of this. All right. Now, let x be contained in Q square. Suppose each continuous function x to R square is bounded, then x is necessarily finite. Is it possible? Okay, let me ask you one question. Suppose each continuous function is bounded, then x is necessarily finite. Okay. If I take x as unbounded set, can you find a continuous function such that this f is unbounded? We want identity. Very nice. So if we take x as an unbounded function, then we can easily get a continuous function which is identity, which will give the image as unbounded. So we can't take X as an unbounded solution. So we have to take, to get the count example, first of all, to get the count example, we need to pick bounded set X. This is the first point. Because if you take unbounded set X, then the identity function is a continuous function which will take unbounded to unbounded, and we won't be able to make a counterexample. Second point, X can't have a limit point. Limit point outside. That is, X have to be closed. Why? Somebody tell why? Because if alpha is equal to alpha 1 comma alpha 2 is a limit point of X, then such that alpha 1 comma such that alpha do not belong to X, then one can define this function right, and it is an unbounded function, right?
Yes.
Yeah, it is a unbounded function and also continuous. So it is X we need to take as bounded set, also a closed set, right? Also, to get the count example, we need X as infinite. Do somebody know such a set? Which is bounded, closed, as well as infinite, and a subset of Q square. Let me give it a set. Let A equals to it is a closed set. Take B as 0. Now take A cross B, which are element as A comma B. A belongs to A, comma B belongs to A. Is it such a set that I have defined? Or take it plus, even doesn't matter. So X is such a set. Now if you define any continuous function from X to R squared, it will be bounded by
It's a compact set.
hello.
Yeah, it is a compact set and continuous image of a compact set.
Yeah, very nice. Can somebody turn their mic off? Yeah, a lot of noise is coming. Okay, so yeah, so the reason is A cross B is a compact set, and continuous image of a compact set is compact, and it is compact because of Hien-Borel theorem, right? It's compact because of Hien-Borel theorem, and continuous image of a compact set is compact, and compact set is bounded, and hence this is bounded, so this thing is false. It may not be necessarily finite because we got an infinite example. No. 0 is a limit point of set A, which is contained in 0 to infinity. Then set of all x belonging to 0 to infinity that can be expressed as a sum of elements of A is dense in 0 to infinity. Okay. First of all, it is true, let me tell you. And the reason is for this particular thing to be true is because 0 is a limit point of A. So A has element as small as you wish, right? So when you get all the elements that can be as small as we wish, then we can utilize them to approximate any number possible. And you will see that how I will do this problem. So since correct. So what you do, you choose epsilon. Epsilon greater than 0 and divide. What I will do, is to prove that a subset of A is dense in 0, 1, and then we can generalize it to 0 to infinity. In intervals of length epsilon, okay, and call P equals to summation I equals to 0 to n ai, ai belongs to A. So what is the set? B is the set which is we want that express. B is the actually the set of all elements that are expressed as sum of elements of it. Okay, so call B as this. Then what will happen? Suppose I break 0, 1 into parts. 0, call it x0, and take the last element as xk, xk minus. Okay, what will happen then? Is equals to epsilon, and then what will happen? There exists A belongs to A, such that A is less than epsilon. Is it correct? And obviously A is greater than A is a subset of epsilon. Is it possible or not for any given epsilon? This will imply this will imply is less than xi minus 1, because we took epsilon as that interval. It will imply xi over A minus xi minus 1 over A is
Greater than 1.
, which will imply that psi minus 1 over a comma x psi over a contain a natural number, isn't it? Any interval which has length more than 1 have to contain a rational number. I have to contain a natural number, because at most natural numbers can be far apart. Two consecutive natural numbers can be far apart as 1, and the length of this interval is 1. It implies that actually there exists n belongs to n such that n belongs to this interval and this will imply an, sorry, this will imply n a belongs to this xi minus 1 comma xi, right? And since na is nothing but element of b, it is the n times sum of element of a, it implies that there exists b equals to na belonging to b such that b belongs to this interval. It implies that. Isn't it? Because length of that interval was epsilon. And this b also belongs to this interval. Hence, since epsilon was very small, so b intersection, or I can call b itself, b is actually dense in a, sorry, dense in this interval. First tell me, is everything clear till now? Because I choose the epsilon arbitrarily, what I showed is that a randomly chosen interval or a randomly chosen element of that sub-interval has a difference of less than epsilon with the element of b. So since epsilon was arbitrary, so b have to be dense in 0, 1, interval 0, 1. Is it fine? Or do somebody have doubt? Please tell me right now. Okay, so I hope you people do not have a doubt. So it is dense in A. For rest of the thing, what you do, take any x belongs to 0 to infinity. Okay. What we can do is we can write this x as this. Now, since x is less than 1, so it will belong to one of those sub intervals that we divided. So there will exist some b such that minus b is less than epsilon, right? Moreover, since 1 also belong to one of those intervals, the last element will be 1. Sorry. It should be xk minus 1, and it is xk. That xk is actually 1. Since xk equals to 1 and that belong to one of those intervals, so there will exist some b again, call it b1, and there will exist some b again such that 1 minus b2 is less than epsilon, and then it will imply x minus box b2 plus b1, and this b2 plus b1 is an element of b again, a again, because it is a sum of two elements of a, is actually less than epsilon plus this. And since epsilon is arbitrary and this element is actually belonging to b, so this set b is dense in 0 to infinity. Is it fine? Tell me. If it is confusing for you people, you can ask me doubt right now. I will explain a step or two once again if you have any doubt. Do anybody have doubt? Should I repeat the last part again?
Yes, sir.
Yeah. Okay. So is it clear till that B is dense in 0, 1?
Yes, sir.
Okay. Let me erase this and I will explain this part again. Till now what we did actually, we subdivided this 0, 1 into intervals of epsilon length. Then for any random chosen I, this ith interval, it will contain an element of B. So since I was chosen arbitrary, that ith interval was chosen arbitrary, and the bi is the arbitrary element of that arbitrarily chosen ith interval, and the difference of B and bi is less than epsilon, so B is dense in 0. Now the rest of the things I'm telling you. So let me explain the rest of the things in this space. See, what we proved is B is dense in 0. Okay. Now we have to prove rest of the part. So what I am doing, let epsilon greater than 0 is fixed, comma, let x belongs to 0, comma, infinity. Okay. Tell me, please reply me in yes or no, that if I am able to find a B belonging to B such that B minus x is less than epsilon for this epsilon, then can I say that B is dense in 0 to infinity? Tell me. If I can prove that B minus x is less than epsilon for some B belonging to B, then can I claim that B is also dense in 0 to infinity? Is it or not?
Yes, sir.
Yes, sir.
Okay. So I will prove that it is less than epsilon for some B belongs to. Okay. Now, break x into two parts. Integral part of x plus fractional part of x. First thing is that fractional part is always strictly less than 1. So this implies that this belongs to, correct? Now by density of B in this interval, we can say by density of B, we can say that is this statement clear till now? Second point.
Yes, sir.
Again using by density, Can I call it? Okay, let me call it B1. Okay, yeah. So by density of B in this, can I say that there exists some B2 such that this is less than epsilon?
Yes, yes.
Now, what I can do is that by using, so now I can multiply this whole inequality by integer part of x. And can I write this as this? Fine, because integer part of x is greater than 0. So I can multiply this. Right? Now, this will imply actually x minus b1 plus box b2 is equals to is it fine? Now by triangular inequality, this thing is less than and which is actually less than 1 plus integer part of x epsilon. Is it fine? Since epsilon was arbitrary, it can be made as small as you wish. Hence, and this element b1 plus, since greatest integer x is again an integer, so this also belongs to b. Okay, and hence b is dense in 0 to infinity. Is that fine till now?
Yes, yes.
Or you can actually call this this as b dash or something, and then you can write this as this. Okay, and we are done. Okay, I hope it is clear to everybody, right?
Yes, sir.
Okay, now next problem is, this is also a very nice problem, and what it says, there exists a uniformly continuous function f such that this thing converges. Can we say that? First, let's see by the example. If I take fx equals to x, it is a continuous function which is uniformly continuous on 0 to infinity.
Yes, sir.
Is it convergent or divergent?
Divergent.
Divergent.
Divergent. Very nice. And what about root x? Is it uniformly continuous on 0 to infinity?
Yes, yes, sir.
Yes.
Okay. And is it convergent or divergent?
Divergent.
Divergent.
Divergent, sir.
And what about then sin x? Sin x is uniformly continuous or not?
It is uniform continuous.
Uniform continuous, sir.
What about this series? Is it divergent or convergent?
Divergent, sir.
Why?
The sequence does not converge to 0 on my side.
Yeah, very nice. So because limit n goes to infinity, sign do not exist, so we can't say that this goes to 0 or something. So this is also. So again, I use some examples and I'm observing that it may not be possible for it to be convergent. So I will now try a proof. See the proof. If limit n goes to infinity, fn is net, then we are done. Otherwise, what we can do, it will go to infinity actually. Otherwise, limit n goes to infinity, Fn is equals to infinity, and pick epsilon equals to 1. What will happen with this epsilon? You can have delta greater than 0 such that is it fine? Why I can write this? Because of uniform continuity given. Right? Because of uniform continuity, I can write this. Now, what will happen? For some n, take the interval n comma n plus 1. Divide it into intervals of length delta. So call this as n comma by 1 union by 1 comma by 2 and so on up to some by k minus 1. Sorry, n plus 1. N plus 1. Now, what will happen? This quantity, I can write this as by triangular inequality, right? Is it correct or not?
Yes, sir.
But since length of all these elements is less than delta, so by this equation 1, all of these have to be less than 1, right? And one more thing, if length of each interval is delta, then how many such intervals are possible?
One by delta.
1 over delta. Very nice. This quantity is less than 1 for each interval. And how many such ones are there? There will be equal to number of intervals. So this will be less than 1 over delta. Over delta. Very nice. So this quantity is actually less than 1 over delta. Now again, what I can do, I can apply this formula recursively, and I can write this as Fn minus 1 plus Fn minus 1 minus Fn minus 2, correct? And so on up to F2 minus F1. And there will be n such elements, so this quantity will be less than n over delta. Sorry, yeah, n over delta. Is that fine? Is that
Yes.
fine or not? It implies that Note that f is from 0 to infinity to 0 to infinity. So this mod doesn't make much sense because all the values are already positive. Can you tell me from this? Sorry, it should be 1 over.
Yes, yes, sir. You know.
Does it imply that 1 by fn is divergent?
Yes, sir.
Very nice. Do anybody have doubt that this condition will imply divergence of the 1 over fn? Tell me quickly. First, do anybody have doubt that summation 1 over fn is diverges? If anybody have, I can prove. Or should I move on?
No doubt, sir.
Very nice. Okay, so this is actually false. Now, this is also an interesting problem. It is given that it is a monotonic increasing function such that f0 is greater than 0 and f1 is less than 1. Then there exists ix such that fx equals to x. And in the bracket, they have especially mentioned that not necessarily continuous, right? Because if it would have continuous, we can easily apply intermediate value property to prove that there is some fixed point, fx equals to x. And I hope some of you must have seen the proof that we take a function gx and then apply g0 is greater than 0, g1 is less than 0, implies there exists some y such that gy is equals to 0, it will imply fy equals to y, right? But it is not the case here. It is given that not necessarily continuous. So any guesses for this question? Tell me first. We have very less time. But the condition that monotone increasingness will allow us to use that intermediate value property. Although I will not apply directly, I will give a rigorous proof that how it is actually happening. So let me begin. Call a set A so that this quantity is this. All right. Okay. Now, what you do? If A is bounded above, should it have supremum?
Yes, A is non-empty.
Why?
0 belongs to.
No, I mean, why it should have supremum? I'm asking.
It is non-empty, sir. 0 belongs to A.
F of x is the upper bound.
Oh, okay, yeah. Yeah, so yeah, first of all, I have to tell, yeah, this is non-empty set because of course 0 belongs to it. Yeah, so 0 belongs to it and it is a non-empty set and it is bounded above. So it should have a supremum, right? Now, since it has a supremum, call bi as the supremum of this. What can we say about this bi? First of all, bi is less than equals to x, isn't it? Sorry,
Greater than or equal to.
other way around. Greater than equals to x, right? Also, it is given that f is monotonically increasing. So can I write it will imply f bi is greater than equals to fx?
Yes, sir.
Okay. Now, can it imply x is less than equals to f bi? Or I mean, can I write this? Can I write this? This is the property of the set A, right?
Yes, sir.
Yeah, this is the property of the set A. So I can write this. So by the last step, I can write x less than equals to f bi. Now take the supremum on both sides and we can say this. Is it fine? Tell me first.
Yes, sir.
Yeah. Bi is less than equals to f bi. Now since f is monotonic, I can take again f bi. Is it fine?
Yes, sir.
Now, if f bi is following the property that f bi is less than equals to f of f bi, then isn't it f bi belong to A by the definition of A?
Yes, sir.
It implies that f bi belongs to. Correct? Correct or not?
Correct.
Yeah. So if f bi belongs to A, then it will imply f bi is less than equals to bi. Why? Because bi is the supremum we took.
Yes, sir.
Okay. This is 1. This is 2. Imply f bi equals to bi. We are done. Using 1 and 2, can I write f bi equals to bi?
Yes, sir. Of course.
Yeah, of course. So this is true, right? Yeah, this is true. This is not very hard problem. Let me see how many problems I'm left with. 1, 2, 3, 4. Okay. Actually, I have a set of MCQs also that are left to do. So maybe I will leave 1 or 2 problems for you people. Yeah. So let me leave this problem to you. This. And I will actually leave with a hint. And is that first of all, limit n goes to infinity, root n is 0. So after some point, And also an over n raised to 1 by 4 is less than or equal to n. Apply these two things with some with some modification or some writing, and you will get the answer. Is it fine? Should I leave? Should I do it? I'm leaving to you, okay? If anybody have doubt, you can ask later or in the end. Okay, this is an interesting problem. There exists a differentiable function f from R to R such that this follows. Is it even possible? And there is a very nice exercise. I think it is given in Introduction to Real Analysis by 𝕨𝕨𝕩𝕨𝕩𝕨𝕩. So in that book, they have given one such problem, I remember. So we will kind of utilize that. It is given that f is differentiable and limit x goes to infinity f(x) equals to 2 and limit x goes to infinity f dash x equals to 1. Is it possible to have such a differentiable function? And it is not. See why. Since fx, this limit is finite, so can I write like this? Now apply limit. Can I apply L'Hopital rules? Is
Yes, sir.
both functions in numerator denominator follow the condition enough
Yes, sir.
to apply L'Hopital? Yes, they follow. So I can apply L'Hopital rule and we will have f dash x over e raised to x, right? To simplify, and again we can cancel out the both functions and we will have this. And also it is, we assumed that if limit x goes to infinity, fx exists. Yeah. Can I write like this? And by exist means it may be infinity also. Okay, it may be infinity also, but it should exist. It is not that right hand or left hand or whatever it is. So this is the condition that you get. Is that following with the question? It will give you 2 equals to 3, I guess, right? And which is not possible.
Yes, sir.
Contribution. And actually the theorem is, or that problem is, let me write here. If limit x tends to infinity, fx plus f dash x equals to L, then and this is the exercise in 𝕨𝕨𝕩𝕨𝕩, so you can refer to that in the section L'Hopital rule. And I think almost 7 to 8 problems till now TIFR asked based on this observation. So maybe this time also, nobody knows. Now one more interesting problem that is asked in last test. TIFR. There exists a homeomorphism F from R to R such that f of 2x equals to 3 times fx for all x beyond R. Is it possible? Anybody have any idea? See, it is asking the existence of homeomorphism. Can somebody tell me a simple homeomorphism from R to R? At least one.
Identity function, sir.
Identity function. Fx equals to x. Is fx equals to alpha x? Is it a homeomorphism for any alpha belong to R?
Yes, sir.
Is
R
an-
minus 0, like
yeah,
alpha should not be 0.
Yeah, alpha should not be 0.
yeah, of course, alpha should not be 0. Very nice. Is x cube? Is it a homeomorphism?
Yes, sir.
Yes.
Yes, sir. Inverse is cube root of x is continuous.
Yeah, inverse of this function is also continuous. So these are the some known homeomorphisms. See, when I begin with this is the very this is one of the basic functional equation that they have given. So we need to find one homeomorphism which satisfy this functional equation. So to have the idea, let us begin with something like x raised to alpha. Okay. Will that be fine? And now let's apply this condition and see if we managed to get something. First of all, let me tell you. I tried to see this thing. I tried to see this linear function, that will it satisfy this or not. But this linear function will not satisfy. So next best thing that we can see or we can take a chance with is x raised to alpha. Let us see. So what will be f raised to x is nothing but 2 raised to alpha times x raised to alpha, and we want it to be equal to 3 times x raised to alpha. Right?
Yes, sir.
What does that mean? Can we find alpha here?
3 should be equal to 2 over alpha.
Just give me a minute, okay? Yeah. So this will imply alpha is nothing but log
Base
cube.
50.
Is it a homeomorphism? Is it? Tell me.
Yes.
No, you can't say that. Tell me first, is it even a defined function on R? Or maybe to make it more simple, is x raised to pi is defined on R? And for your information, let me also tell you that log 3 over log 2 is a irrational number. Tell me first, is x raised to pi is defined on R? And answer is no. X raised to pi is only defined in zero to infinity. So this can't be the homeomorphism, but we can actually modify such function. See the modification now. Let me define such some gx. So that it is minus of minus x raised to log 3 over log 2. X is less than or equal to 0. And x is to log 3 over log 2. X is greater than 0. No. Is it a homeomorphism? First of all, it is 1, 1 and onto. You can verify easily. Right? Can anybody answer? Is it 1, 1 or not? Or it is 1, 1 onto or not? Hello? Hello, am I audible?
Yes, sir. Audible.
Yeah, so is it 1, 1 and onto or not?
I think not, sir.
Why? See, it is 1, 1 and onto. Not 1 onto, it only continuity problem is that can occur is on the 0, and you can verify it is continuous on 0. Or like it will have this graph also. If you see, it will have some graph like this, something like, and then something like. Can somebody verify is it 1, 1 and onto or not? Hello.
1, 1 and onto, sir.
It is actually 1, 1 and onto. Also, it is continuous on 0. And only continuity problem will occur on 0, and since it is continuous on 0, so it is continuous on all R. 1, 1 on 1, 1 onto on R, continuous on R. Now only thing left is to check the inverse function is continuous or not. Right? To check the inverse function, this I will leave as an exercise to check that gx map a open ball to open ball, or maybe open interval to open interval. All right. This I will leave you as an exercise, and note that if G map open interval to open interval, or G is a open mapping, then the inverse function will already be continuous, and hence it will be a homeomorphism. I hope most of you must be knowing that if a function is a open map, then the inverse function is already continuous, right? Because of the definition of continuity in terms of openness, right?
Yes, sir.
Yeah. So Gx will map open interval to open interval. You can verify. This 1, 1 and onto straight away you can verify. Continuity you can verify on 0, and otherwise it is already continuous, and hence it is a homeomorphism. And from now onwards, you can also should not say that x raised to pi is defined on all. And if you see the definition of x raised to pi, because it is not some natural or rational number, so sometimes, or like there are different definition, but most times we may define this x raised to pi as the limit n tends to infinity x raised to some Rn, where Rn is a sequence which tends to pi. Okay, this is how x raised to pi is defined. And why it is not defined on negative numbers is because Rn could be negative also, and we know that Rn could be rational number also, for which x raised to Rn is not defined. For instance, x raised to half is not defined on negative numbers, or even x raised to any rational number whose denominator is even cannot be defined on negative real axis. So because of this fact, x raised to pi cannot be defined on negative real axis. Okay, so we made a function fx and then we extended it a little bit to get what we require. Done. All right, this is the last problem, MCQ problem. There exists a continuous bijection from this set to this, which is not a homeomorphism. Can somebody answer me quickly? Is it true or false? Last one was true. Tell me first. Is it true or not? Can somebody tell me about the homeomorphisms from compact sets to Hausdorff spaces? Is this space? Sorry. Is this space with respect to usual? Also, I mean, it is a metric space actually, and all metric spaces are Hausdorff spaces, right? Right or not?
Yes.
Now, if we have a map which is continuous and bijective from a compact set, this interval 0,1 cross 0,1 is compact, right?
Yes.
Okay. So a map which is continuous and bijective from a compact set to Hausdorff space or compact space to Hausdorff space, is it always a homeomorphism? It is a standard theorem in topology or mathematics spaces. So let me do it. What happens if you have a map which is continuous bijective? Okay, if f is continuous bijective and we want it to be a homeomorphism, what is left to do?
Inverse is continuous.
Need to show the
Inverse.
inverse.
Yeah, inverse is continuous. X is compact and y is Hausdorff. So inverse is continuous if and only if f is a closed map. Am I right?
Yes, sir.
Yes. Now, do you know that compact spaces in a Hausdorff space are closed?
Yes.
Yes. So what will happen if you take some image of some, now also if, okay, let me write it properly. It's closed. then it will imply A is compact. Closed subsets of compact set is compact, right?
Yes, sir.
Compact in bi, because continuous image of a compact set is compact, and then it will imply F is closed because bi is given as Hausdorff, right? So we begin with a closed set, and we got image as closed set. It imply F is closed map, and hence the inverse function is also continuous, and hence F is a homeomorphism, and hence it is a true. Done? Okay, let me quickly begin with the some of the MCQ problems. I'm sorry.
That is false, I think.
It was
Why?
false, right?
Yeah, it is false.
Oh,
Then it
no.
is not a homeomorphism.
Oh, it is not homomorph. I'm sorry. Yeah, every such map have to be a homomorphism, so it is false. Yeah. Okay. Now, this problem was asked in last year TIFR. So here's some quick observation that you should make. First observation is that fx is equals to f of 1 by x. Isn't it? First observation is f of x equals to f of 1 by x, and it will actually imply if you take composition n times, then also this fact will remain same. All right. So first observation you should make is that okay, let me read the question first. This fx is given as this function 3x square plus 1 over x square plus 3. What they're saying, take the n compositions and denoted by this symbol. This denote the composition of functions n times. Okay. Now they are asking question based on this. So first observation based on this problem is that fx equals to wait. I think I did one mistake. Just a second. Let me work it. 3 over x square plus 1 over 1 over x square plus 3. Yeah, so it will become 3 plus x square over 3x square plus 1. Yeah. So it is actually 1 over. Oh, I'm sorry. It should be 1 over this thing. Okay. And similarly, you can also prove that. Keep going. And by using induction, you can prove that this property will hold. Okay. Now, what will happen? It will imply 2 equals to 1 over 1 over half. Correct?
Oh, no, 2, sir.
Yeah. So what will happen? Either both the limits exist finitely, okay, or both do not exist. It can't happen that one exists finitely and other do not, right? So this B and C option is incorrect already. Because if other one is 1, the other limit have to be 1, right?
Yes, sir.
Yeah. So both the option is incorrect. Second thing is that if you see FOF, F of F and all, then you will see this. These are the something of the kind this. Or what I mean is that Just a second. Yeah, power 4 and then power 8. So they are something of the kind, or I mean, let me write k or p is something. If I okay, let me actually find f of f, then I will see something. Okay, and if you plug in that, then it will become 3x square plus 1 over x square plus. Am I audible now? I'm sorry, my
Yeah.
audio.
Yeah, yes.
Yeah. So okay.
Yes. Uh, yeah, yes. So, shall we move to the feedback session?
No, sir. Just let me finish this problem, one or two problems.
Okay.
Then, yeah.
Okay.
So what I was saying is that this limit will exist finitely, and since this limit will exist finitely, the other limit, because of this relation, have to exist finitely. So only option correct is first one. So like, what amount of time I have? Should I proceed or not?
Our time is almost exhausted, but you can go for five more minutes.
Okay. So let me do one more good problem. Yeah, I guess let me do it. This one. What it says, we need to find a limit n goes to infinity 0 to 1 minus sine 1 over n fn x dx. And you have given some complicated function, which is defined as. Now, usually what happens whenever we see these limit problems, first thing that we comes in our mind is uniform convergence and related things. First of all, let me tell, because f of n 1 by n, if you find out, it will become sin n plus cos e raised to n over n and upon 2. Because of this, as n goes to infinity, this will not exist finitely. So fn do not converge uniformly. And as n goes to infinity for a fixed x, this quantity will go to 0. So it will not converge uniformly to 0. So we can't apply that method that we used to, but we can do something else. Idea is to use an inequality. See, limit n goes to, this quantity will be less than or equals to limit n goes to infinity. And I can take this modulus inside of the integral. And it will become Is my screen visible to you all?
Yes.
Yes, sir.
Yes, sir, visible.
Oh, okay. I guess we should stop it here because my system is lagging a bit. Okay. Maybe I will write the solution of that problem and will end here.
Yeah, that will be better.
Yeah.
We can, if you could share the PDF with the details of the workout problems, then we can share it with the recording of this.
Yeah.
Okay, thank you, Aviral, for this nice session with a good collection of problems, and you have explained the major part of TIFR examination. There will be a lot of problems which are to be answered as true or false. So you have explained that type of questions with a good collection of problems. So I'm sure that this session will be, our participants are really benefited out of your session. Okay, now it is the time for feedback. So dear participants, feel free to share your thoughts about today's session.
Good evening, sir. I'm Shikha, and I've completed my integrated MSc from in mathematics and computing from Bijumon, Jharkhand. And right now I'm preparing for CSIR NET. And today's session was really very informative and full of concepts. And the proof was really very much clear and very much like we can grasp it very nicely. And I hope that all the that today's session will be very much helpful for our upcoming exams. And thank you, sir, for your time. We are hoping for more such sessions from your side. Thank you so much. Thank you, Vinod, sir, for organizing such sessions. Thanks a lot.
Thank you.
Thank you, Shikha.
Yeah, others, feel free to share your feedback. Yeah.
Good evening, sir.
Yeah.
I am Rajavel from ISET TVM, sir. Actually, I very weak in real, sir, but your questions and problems are somewhat I can think and answer, sir. And one question I am gets excited is that a function from 0 to 1 to r, monotonic increasing, which has a fixed point. That is very amazing, sir. Thank you, sir.
Thank you.
Yeah, thank you, Rajswell. Yes, others. Okay, dear
Hi, sir.
participants. Yes, Gopika.
Sir, my name is Gobika Sunil. I'm from St. Thomas College, Thrissur. I'm currently preparing for JAM examination. I found today's session really useful. I was able to learn a lot of new concepts. Thank you so for the session. Thank you, Vinod, sir, for organizing the session. Thank you.
Thank you, Gopika.
Hello, sir. Am I audible?
Yes.
Sir, I'm Anamika. Now I'm preparing for IT JAM examination. I felt little difficulty in each problems, but the questions and your explanation was really nice. I enjoyed a lot. Thank you so much, sir, for this session. Thank you, sir. Vinod, sir, too.
Thank you.
Yeah.
Good evening, sir. I am Ananda from St. Teresa's College, Ernakulam, Kerala. I'm preparing for IIT JAM. I'm third year BSc Math student. And sir, your class was really informative, and I hope it will help me more in my exams. And thank you, sir, for spending your valuable time for us. Thank you, sir.
Thank you.
Thank you, Ananda.
Good evening, everyone. My name is Priya Singh. I have completed my MSc from NIT Surat this year. It was a really informative session. Like I knew the concept, but in the way they were applied, that were really great. Thank you a lot.
Thank you, Priya.
Thank you, Priya. Yes, Praveen, you can speak something. You are really very active in the class, so it will be very nice if you can share your thoughts. Praveen Kumar.
Yes, sir. I enjoy the session a lot, sir. I enjoy the method in which he approached the problems.
Thank you, Praveen.
So, Praveen, could you introduce yourself? You are studying where?
Sir, I'm an MSc graduate, sir, from Jamal Muhammad College, Tiruchirappalli. Graduated on 2022.
Okay. Okay, Praveen. Yes. Any others?
Hi, sir. Good evening. My name is Sandana and I'm from Kerala. So, first of all, thank you so much for taking this session. The way of approaching the questions, answering and explaining them were so understandable. And once again, thank you so much for spending your part of day with us. And thank you.
Thank you, Vandana.
Thank you, Vandana.